Welcome back to another Terran R monthly update. Let's dive in and recap key milestones from September. This month, the team completed 19 component-level critical design reviews, mainly focused on the second stage vacuum engine and secondary structure trays and manifolds. There is a key focus on releasing all second stage components ahead of manufacturing need dates, and the fluids team released more than 150 machined components in September. First stage tank welding continues, with 3 circumferential friction stir welds now complete. In parallel, primary structure tanks have also begun being painted on our on-site paint booth. The Stage 2 tank has been painted, and sections of the Stage 1 tank are being painted before being welded into the larger barrel. In engine manufacturing, the team wrapped up assembly and final integration of the second engine for first flight. Additional machinery is coming online to enable high-volume engine production. In the past few months, we've reduced cycle times on average by 50% across key engine components, and these additional machines will help speed up production even more. The avionics team is building the Flight Hub box, which acts as Terran R's central unit for routing data and distributing power to critical systems. After an extensive acceptance test campaign, the first flight thrust structure is now undergoing integration. This includes mounting secondary structures such as brackets, fluids, avionics, and more. Work on the Flight 2 thrust structure is also underway, with panel milling and stringer welding taking place alongside subassembly manufacturing. The team wrapped up thrust structure acceptance testing in Long Beach this month. The structural test stand was reconfigured for ground case testing, demonstrating the thrust structure's ability to keep Terran R clamped down during events like static fire. In this test, we successfully applied a total of 3.7 million pounds force of tension through the thrust structure hold downs, with a peak tension load of 478,000 pounds force in one hold down. The team then completed the handling test case, which demonstrated the thrust structure's capability for critical operations like lifting on the transporter erector. The team completed power and communications checkouts on hardware in the loop for the thrust structure avionics on the path to integrating a full vehicle HIDL this year. Vibration testing of components continues, including successful test of the high voltage power distribution box to stress levels that would be required for qualification. At NASA Stennis, acceptance testing of the first flight engine kicked off, and development testing of the second stage vacuum engine continues. Recent wins include hot firing Aeon V with densified liquid oxygen, performing a 475-second mission duty cycle burn, and conducting suction tests to build out and confirm the Stage 2 run box. But the focus isn't just on first flight. Engine enhancements for future engine block upgrades are already underway, with igniter component testing for AR 2.0 in the works. These upgrades aren't necessary for early flights, but will help unlock additional performance in future iterations. On the A2 test stand, the team installed liquid nitrogen, liquid natural gas, and liquid oxygen permanent storage tanks in place, paving the way for commodity flows for stage testing. We also activated the first stand automation, bringing together data, ground software, fluids, network, and data and control systems hardware to run our pneumatics panel at the LOX pad. At Cape Canaveral, the horizontal integration facility has been fully framed with steel, and siding panels are now being mounted. Just north of the HIF, deep foundation piles are being installed for the pad's lightning protection system, which will consist of 2 towers standing at 531 feet tall. The fluids team erected 2 30,000-gallon liquid oxygen tanks at the propellant farm, with more tanks on the way. This month's progress reflects not only readiness towards first flight, but the foundation of a program built for repeatable and scalable launch.